NASA's SPHEREx Observatory, delivered by BAE Systems, will map the universe in infrared light, exploring galaxy formation and dark energy. The project reflects years of innovation in compact, high-precision instrumentation for space exploration. Challenges, though, do include designing hardware that could endure extreme temperatures and vibrations during launch. SPHEREx is going to open new doors in astrophysics, with potential data breakthroughs expected as early as next year.
The clue is in the news announcement there. Surviving that extreme launch and space conditions without the system being damaged, degrading, etc. So I think the biggest challenge isn't just building this SPHEREx, it's making sure that its precision instrumentation will function flawlessly after it survives that violent launch and the future extreme conditions of space, of course. So biggest issues, you've got vibration, shock tolerance, you've got thermal stability in space, you've got longevity of optics and electronics. Big ask in extreme conditions.
Now, longtime viewers of our little show will know that I like a good acronym, and I just have to point out here. So with BAE Systems having successfully delivered NASA's spectrophotometer for the history of the universe, epoch of reionization, and ICE's Explorer.
They came up with the acronym first, didn't they?
Oh yeah.
You couldn't tell.
This has been, going for the observatory that's going to be on the Space Force base in California. The observatory is scheduled to launch in late February alongside NASA's polarimeter to unify the corona and heliosphere, or PUNCH mission aboard the SpaceX Falcon 9 rocket. So we've got the SPHEREx to deliver a punch, and we're looking for a 2-year mission that's going to conduct the first all-sky spectral survey, gather this information to help look at the questions about the universe, which for me, the question is, can the sphere generate useful game-changing data once it's up there in space outside of our earthly sphere? So it's close to in line with what Andrew's talking about, of how is it going to function once it's up there? How does it survive the launch? And once we're there, is it going to actually be able to get that data and use it, make it useful, make it something that actually, so the whole mission actually matters?
You're thinking way too far ahead there, Brian. I'm afraid. Yeah, that SPHEREx is way off. SPHEREx is useless if it doesn't survive the launch. We're talking about an observatory that has to endure violent G-forces, not just violent, function at near absolute zero, and remain precisely calibrated for the years ahead without any human intervention. I mean, I guess this is why they're called rocket scientists, but if something shifts even slightly, NASA could end up with $1 billion telescope that's giving them fuzzy images instead of unlocking the secrets of the universe. Survival isn't a given. It's the first battle in my mind.
Even worse, a paperweight just floating in space.
No,
that wouldn't be a paperweight, would it? It's floating.
Yeah,
it's gravitational.
Sure, we'll go with that.
So, Andrew, you've accused me of thinking too far ahead here. I'm going to say no, I'm not thinking too far ahead. I'm simply asking if the product is going to do what it's meant to do. This is effectively a requirements question here. The SPHEREx is going to use an advanced imager developed by NASA's JPL at Caltech to survey the entire sky in near infrared light, create 3D colored maps of 450 million galaxies, seeking out water and life-sustaining spheres. In order to do all of this, to deliver these results and to keep delivering them in that harsh condition you're harping on, yes, it's got to launch and get there, but it's also got to function once it's there. So, and you can't just go up and repair it once you're up in space.
True. And there's no debate. I think you're absolutely right. It's just a secondary issue, and it's thinking too far ahead. No. Seriously, what's the solution? Simulation and testing for launch. I think that's the first thing. Run your AI-driven simulations, standard simulations these days. to test and adjust for these kind of thermal shifts it's going to go through, launch stress it's going to go through, and then use your digital twin model to reenact those space conditions and therefore kind of preemptively correct any misalignments as you go. So that's the first solution.
And then you want to look at with some of the smart factory solutions to have vibration resistance, space hardened components, things that are going to survive what you just did your simulation to test to see what do we need. Look at supply chain integration to make sure that you've got any specialized materials, any redundancy in critical electronics, because eventually some system's going to fail. So you got to make sure that it is just ready to go and survive without a lot of maintenance, because currently we don't have the technology to easily maintain things out in space. But that could be coming.
This is really tricky stuff, isn't it? I mean, that design's got to be amazing with its material usage. You've got to simulate it for launch and when you're up there, and your production and your supply chain has got to be in sync. It's a true critical thread play for us.
It's a lot.
See you next week.